Oh no, I was going to say the next slide as well. So these are, this is a histogram showing when patients died. So most patients died on the first day. So 700 and so patients died on the first day. And then, you know, so people die, you know, really quickly. So these are the results. 7 years work, 10 years work, just 2 lines of results. So statisticians in the room, look at those results and tell me what, you know, what do you think? Anybody want to offer an opinion?
So as you said, very low GCS number without very very serious about very hemorrhage was not so. But maybe that people who have a head injury, maybe some have a heart attack or like as you can say alcohol or like a benzodiazepine or something like that.
Okay. So let's go through the results. This is the main result, the primary endpoint. So this is the tranexamic acid group. There were 18.5% dead in that group, and there was 19.8% dead in the placebo group, and the relative risk was 0.94, and this is the confidence interval, 0.86 to 1.02. And then in the sensitivity analysis, where we excluded patients that we didn't think had a potential to benefit, we had 12.5% dead in the tranexamic acid group and 14% dead in the placebo group, and a relative risk of 0.89 with a confidence interval of 95% confidence interval of 0.8 to 1.
So that value is between in the 95% confidence interval.
This is the 95% confidence interval here, yeah. So what do you think, you know, how would you describe these results?
No evidence of benefit.
No evidence of benefit. Really? Why do you say that? I'm very interested that you say that.
Is the 95 confidence interval of your primary outcome including 1.2?
Ah, all right. See, I think you're wrong, and but a lot of emergency physicians would do the same thing, right? You take a result, and you immediately divide. The result is just information, and we could with information. Information, I think, is like inherently continuous, right? It's inherently continuous. And there is no, but lots of clinicians chop it in half and actually sort of jump and make this decision. Is it significant or is it not significant? And I think this, my own feeling is that I think that's the wrong way to consider information. But it's exactly what the problem turning out to be, that some people, a lot of clinicians say, the primary endpoint is not significant, and therefore, that's it. We don't need to consider anything further.
And also the issue, you doesn't say anything about tranexamic acid injection. In addition to that, maybe doctor may did some other things.
So
that every patient will take the CT, GCS3. Maybe GCS3 in most cases doctor will take a CT, but
If you had a choice, who would prefer a 12.5% risk of death to a 14% risk of death? How many people would prefer a 12.5% risk of death to a 14% risk of death? Nobody? Maybe I think there must be either you have different value or maybe you're not understanding me. So which is best, a 12.5% risk of death or a 14% risk of death? Have you got a preference?
I prefer 12.5%.
Yeah, me too. Thank you. So 12.5% is better than 14%, isn't it? Yeah.
I prefer survival without sick relief, not survival alone.
Yes. No, I think that's very important. Yeah, and I have got results about that, and they're coming. But just on the face value of this, so the best estimate of the treatment effect is, let's say this is 0.9 to simplify it. It's a 10% reduction in the risk of death, right? That's the best estimate of the treatment effect, a 10% reduction in the risk of death. But it could be, it could be 20% reduction, or it could be no reduction at all. But no reduction at all, the ends of the confidence intervals are actually, they're not the most probable value. The most probable value is the point estimate. The point estimate is the best estimate of the treatment effect. And it's not the ends of the confidence interval, but it's the point estimate. And you can imagine a sort of probability distribution. So the most probable estimate is the treatment effect itself, and then it gets slightly less probable as you get. But of course, all results are compatible with the play of chance. And there's nothing special about a 95% confidence interval. We could have a 90% confidence interval, and this would be significant at the 90% confidence interval. Or we could have a 99% confidence interval or a 99.9% confidence, and it wouldn't be. So this confidence interval, whether it's 90, 99, 95, it's all completely arbitrary, I believe.
Then why did you include TCS3 and both unreactive patients?
Why did we
include the TCS3 and both unreactive patients? That's his question. Again.
Why did we include them here?
Yeah.
Because
that is a primary analysis.
Yeah. You think we should have changed? I don't know. Maybe we should have. Yeah. Why would that made you feel happier?
You insist on the sensitivity analysis result of the.
Okay, we could go for this one as well. We could say that.
But that's only limited efficacy.
It's limited efficacy. Not a big treatment effect.
Not big, not so impressive.
so I think, if GCS is 3,
Yeah.
and also if we see the big hemorrhage in the brain, and also that position was very fatal area. So we cannot save that patient with Tranexiamic acid anyway. And then in the case of placebos in the emergency department, if the doctors see the CT and then the hemorrhage very serious, they just tend to use a placebo, I think. So that then so which means this data says maybe this kind of tendency we can detect, I think. Or it doesn't say anything about
All right, so I'm going to keep going. So this is what happened at the editorial stage. So the trial, the paper had gone through peer review, and then 2 editors started talking about the accepted manuscript, and he said, and they were, like you, not happy. We'd concluded that tranexamic acid reduces the risk of head injury death. And 2 editors started talking to each other, and they said, well, should it be, can we say it reduces head injury death? And then the senior editor wrote back, and you said, you're right. I'll focus on this. You're right to question this. It's only statistically effective in those with mild to moderate head injury. This is really a neutral trial, but is being given a positive spin in the way we don't allow pharma to write. However, this is not pharma and so close to the magical confidence interval of 1. Wow, that's interesting language, right? So this is a senior editor at The Lancet, and they're talking about statistically effective. I don't know what that means, right? I don't know what statistically effective means. I don't know what a neutral trial is. And I don't know what's magical about 1, right? But this is the language that lots of people use. And this is a statistical editor, an editor at The Lancet. So we've really got this thing that it's all about hypothesis tests, isn't it? And it's all about p-values. And it's all about the arbitrary dichotomization of results into being positive or negative based on p is less than or more than 0.05. And I think this is a illness that's common in medicine, and it needs to be cured of it. But
I think pathologically speaking,
yeah.
if the brain hemorrhage is kind of small, the tranexamic acid may prevent worsening of the hemorrhage, because tranexamic acid is the phenylates inhibitor. But if the hemorrhage is too big, so we cannot save anyway with tranexamic acid.
Well, I'm going to come on to that now. But anyway, so I think all of this is very interesting. A neutral trial, you see, the reason he called it neutral is that this view that if the p-value is less than 0.05, it's positive. If the p-value is more than 0.05, it's negative. But if the p-value, as it was in this case, is 0.05, it's considered neutral. So it's not strictly dichotomous. There's a third category called neutral, that if the p-value is 0.05, in this case the p-value was 0.053. Right? 0.053. If anybody really believes that 0.053 is materially different from 0.047, for example, I don't understand it. I think this is not the way to deal with medical information, but it's the way we do. And in fact, recently, there was a big piece in Nature about medical scientists rise up against statistical significance. So this was an article that had 800 signatories of leading statisticians calling for a stop to the use of p-value in the conventional dichotomous way to decide whether a result refutes or supports a scientific hypothesis. I'm all for that. And it says, we must learn to embrace uncertainty. So we recommend that authors describe the practical implications of all values inside the confidence interval, especially the observed effect or point estimate. Now that makes sense, right? So what you're saying is like, okay, possibly, it could be that there's a 10% reduction in the risk of head injury death. Now that would be, what are the implications for that? Well, first we've got to know, are there any downsides? Is there more disability? Like Professor Furukawa suggested, could there be side effects, more disability? But if there isn't, then a 10% reduction would be rather nice. And it could even be, and it could even be bigger than that. It could be a 20% reduction, or it could be no reduction at all. So not statistically significant does not mean no effect, but most medical, that's what's claimed in most medical journals. And in fact, there's been a recent statement from the American Statistical Society, American Statistical Association on... so it seems that medical statistics invented this thing, the p-value, and now it's trying to distance itself from it to some extent. Perhaps it's not trying to distance itself, but it's noticed that this concept is being abused. That people are dichotomizing results into positive or negative based on this value.